What if I told you the most important tech battle of 2026 wasn't fought under the spotlights of a product launch, but hidden inside one company's pricing blunder, one nostalgic product, and two cards that almost nobody noticed being played? Today we're talking about AMD. But this isn't a product review. This is a chess game, one where AMD appears to be losing the graphics card war on purpose, in exchange for something much bigger down the road. By the end of this, you'll understand why a graphics card that sold 0 units on launch day, and two chips that might reshape the entire industry, are actually two sides of the same decision. A company worth hundreds of billions of dollars publicly called their own product an engineering nightmare. Most companies brag. This one was complaining. Why? Let's start with something that made longtime PC enthusiasts feel a mix of nostalgia and heartbreak. AMD just revived a processor from 2022, the 5800X3D, and called it a 10th anniversary edition. The original became a legend. Thanks to a stacked memory technology built directly into the chip, it punched well above its weight class in gaming, beating Intel across dozens of titles. That was the last great moment for AMD's older platform. The anniversary edition is priced about $100 below that original launch. Those are confirmed facts. Here's where it gets interesting. A senior AMD executive came out and said publicly, bringing this chip back was an engineering nightmare. Not a throwaway line. Because the factory setup TSMC used to build the original chip has been retired. TSMC doesn't keep old equipment running for sentimental reasons. Those machines were shut down years ago to make room for more advanced production lines. That left AMD's engineers with one option: redesign the chip's internals from scratch so it could be manufactured on TSMC's current equipment. Think of it like this. Imagine a shoe company wants to revive a classic from the 90s. The original molds are gone, the original materials don't exist anymore. To make it happen, they have to reverse engineer everything from scratch, new materials, new tooling, so the final shoe looks the same but was built completely differently. That's what AMD just did with silicon. So that modest price reduction you see at checkout? It actually has AMD's re-engineering cost baked into it. That's a reasonable inference based on the executive's public comments, not an official number. Who is this chip actually for? If you're running an older PC setup and don't want to spend big money replacing everything, this is a practical upgrade. Swap one component, get a meaningful jump in gaming performance without touching anything else. But the counter-argument is real. If you're already thinking about a full upgrade, this chip may just delay a bigger spend rather than save you money in the long run. 0 units sold. Not close to 0. Literally 0. On global launch day. This wasn't bad luck. This was the predictable result of one bad decision. Now let's talk about something that's much harder to defend. AMD took a graphics card that was originally sold only in China and pushed it to global markets at $549. Sounds fine on the surface. The problem is in the comparison. This card, the RX 9070 GRE, is a lower spec version of AMD's own standard model. Fewer processing units, less memory, narrower memory bandwidth. Independent testing from multiple hardware publications showed the standard version is about 20% faster in typical gaming scenarios. That's not a small gap. That's the difference between buying the full version of something and buying the deliberately hobbled version. Think of it like this: imagine a car company sells you a sport edition that turns out to be slower, has less horsepower, and comes with smaller wheels than their regular model at the same price. A German hardware retailer that publishes real-time sales figures recorded the global launch day results for this card, effectively 0 units sold. And in the German market specifically, the lower spec card was actually priced €17 higher than the stronger standard model. That actually happened. Some people have defended AMD here. The global AI boom has been gobbling up memory components, pushing graphics card memory costs sharply higher. AMD was squeezed. That cost pressure is real, I'm not dismissing it. But there's an important distinction to make: the cost going up is a fact. The decision to price the card the way they did is a choice. Those are two different things. Facing rising costs, AMD had two reasonable paths. Drop the price to around $450 and compete in a lower tier against a different rival. Or hold the global launch until costs come down. Instead, they chose a third option: put a $549 price tag on a slower card and set it right next to a faster card at the same price. From a business logic standpoint, that decision is very hard to explain. The real damage isn't just this card's sales numbers. AMD spent years rebuilding its reputation in the graphics card market. This pricing decision put a dent in that, and that kind of trust takes time to rebuild. Intel has its own factories. NVIDIA has a decade-long software fortress. AMD has what, exactly? It turns out AMD has been quietly building two things that nobody's been paying attention to. Now we get to the heart of what AMD is actually doing. I need to be upfront here: what follows is based on supply chain reports and industry analysts, not official AMD announcements. This is well-sourced inference, not confirmed product detail. The first bet: more cores than anyone thought possible in a consumer chip. AMD's next-generation processor, based on what's been reported, will pack 24 processing cores into a standard desktop chip. Here's why that matters in plain terms. Think of processor cores like chefs in a kitchen. More chefs means you can cook more dishes at the same time. A few years ago, high-end consumer processors had 8 chefs. AMD is about to give you 24. Until recently, 24-core processors only existed in enterprise servers, the kind of hardware that costs tens of thousands of dollars, requires special cases, and runs up electricity bills that would make you wince. AMD is planning to make that level of processing power available in an ordinary desktop computer at a consumer price. That's the first bet. The second one is the one that should make NVIDIA nervous. The second bet: making the processor itself capable of running AI, so you don't need an expensive graphics card to do it. AMD's generation after that is expected to push core counts even higher, to 32, and introduce technology that lets the processor handle AI tasks directly and efficiently. No separate graphics card required. Right now, if you want to run an AI assistant on your own computer, generate images with AI, or do real-time voice transcription locally, you pretty much need a dedicated graphics card. Without one, it's painfully slow. AMD's future processor is designed to handle those tasks on its own, without needing the expensive add-on. This is AMD walking into NVIDIA's territory through a side door. 3 companies. 1 table. 1 chair. Nobody is willing to stand. And one of them is already starting to wobble. Step back and look at what this means for the whole industry. Start with Intel. Intel's situation right now resembles a department store that was the dominant retailer in town for decades, suddenly watching its best customers drift toward a newer competitor across the street. They're spending billions renovating their own factories, trying to close the technology gap. Supply chain reports have centered on manufacturing yield problems and major customers pulling back orders. These reports have been published by reputable industry outlets, but Intel has disputed some of the details, and specific numbers haven't been independently verified. Hold that with appropriate skepticism. It's not a settled verdict. What's more straightforward to analyze: if AMD's next 2 processor generations ship on schedule, Intel will face direct pressure where it matters most to enterprise customers: how much computing power you get per dollar of electricity. A meaningful gap in that metric translates directly into lost procurement contracts. Intel still has its own factories, deep relationships with enterprise customers built over decades, and government subsidies across multiple countries. Writing it off in advance would be a mistake the industry has made before and regretted. Now look at NVIDIA. NVIDIA dominates AI computing today, and AMD's processor business seems completely unrelated to that at first glance. But ask one question: why does AI computing rely on graphics cards instead of regular processors? Because processors haven't had enough cores to handle the workload. Like a restaurant with 1 chef, great for a family dinner, useless for a banquet. Once you have 32 cores and the right software support built into the chip, a lot of the AI tasks that currently require a dedicated graphics card start to become things the processor can handle on its own. Local AI assistants, AI image generation, voice to text, these could run directly on the processor without a separate graphics card. This doesn't threaten NVIDIA's grip on massive AI training data centers that scale requires entire rooms full of specialized hardware. But in the personal computer market, it chips away at why someone needs a discrete GPU at all. One important caveat: this only works if software developers actually build their applications to take advantage of the new processor capabilities. Hardware routinely gets ahead of the software ecosystem by 2 or 3 years. The transition takes time. This also explains why AMD has been so passive in the graphics card market and why they put out a product as poorly positioned as the 9070 GRE. TSMC's most advanced production capacity is the most fought-over manufacturing resource in the world right now. Apple wants it for iPhones and Macs. NVIDIA wants it for next-generation AI chips. Qualcomm and others are in line. For AMD to secure priority access for its next 2 processor generations, they need to commit enormous resources to that relationship. When resources are finite, something else has to give. The graphics card side drew the short straw. That's my external read of their behavior. AMD has never said this publicly in those terms. Everyone keeps saying AMD is going to win. Let's spend a minute thinking about how they lose. Up to this point, I've mostly laid out the case for why AMD's strategy makes sense. Now the other side, because any honest analysis has to include it. The first risk is price. The more advanced TSMC's manufacturing process, the more expensive each wafer becomes. Every dollar of that cost eventually lands on the consumer's receipt. The first wave of AMD's next-generation processors will almost certainly carry a painful launch premium. That's not speculation, it's what happens every single time with cutting-edge chip manufacturing. The second risk is delays. AMD's ambitious roadmap rests on one assumption: TSMC's new manufacturing processes arrive on schedule. TSMC's track record includes multiple significant delays across past generations. If the next process node slips a year, AMD's entire plan shifts with it. The third risk is heat. A 32-core processor running under heavy load generates a lot of heat. Whether that kind of chip can actually sustain its performance inside a normal consumer desktop tower with normal consumer cooling is an engineering challenge that hasn't been solved in public yet. More cores on paper doesn't automatically mean more performance in practice. The fourth risk is software. Even if the processor is technically capable of running AI tasks, it only matters if software developers support it. NVIDIA has spent over a decade building its software ecosystem for AI developers. Switching platforms has real costs and real friction. Developer inertia is not a small thing. And neither Intel nor NVIDIA is going to sit still. Intel still has its own fabrication capability. Once the manufacturing issues are resolved, it can move quickly. NVIDIA is already developing its own processor chips and maintains a commanding lead in AI hardware. Declaring your competitors finished before the game is over is a habit that tends to backfire badly in the technology industry. We've spent a lot of time on billion-dollar corporate strategy. Here's the only question that actually matters right now: so what? Let's come back down to earth. If you're running an older PC setup, AMD's revived processor is a legitimate option. Meaningful gaming performance gain, no new motherboard required, no new memory required. The rational version of this decision is, you're planning to use this setup for another 2 or 3 years, then do a full refresh when the newer platform matures. Not a forever solution. A smart bridge. If you're shopping for a graphics card, the German retailer data tells the story on the 9070 GRE. Consumers voted with their wallets. Wait for the price to drop, or buy the full-spec standard version with the larger memory. If you're a professional or enthusiast watching AMD's next 2 generations, the underlying direction is technically credible and grounded in real manufacturing developments. But buying at launch on a brand new process node means you're also paying for the early production curve, the firmware development cycle, and the first adopter debugging experience that everyone else benefits from later. Waiting 6 to 12 months post-launch isn't timid. It's just pattern recognition. Now the big picture. The AMD that Lisa Su built over the past decade has consistently demonstrated one thing: don't fight every battle. Find the place where concentrated resources create the highest expected return, and put everything there. That strategy can fail. The manufacturing timeline can slip. the costs can spiral. The software ecosystem can lag 2 years behind the hardware. Any one of those breaks the thesis. But if AMD's next 2 processor generations land on schedule, they represent something more than faster chips. They represent a shift in who gets access to serious computing power. AI won't only live in data centers. It won't only be accessible to people who can spend several $100s on a dedicated graphics card. It'll sit inside an ordinary desktop processor, on a standard motherboard, in a tower that looks like every tower you've ever owned. Whether that's actually the future AMD is building, the market will give us the most honest answer soon enough.